Hello, welcome back to Learning with Ms. H. We are back in Earth Science, and for today we're going to take a look at our Paleozoic Part 1 lesson. So this is going to be a multi-part lesson again, and we're going to start with a quick review of geologic time by putting all of the time frames in order from earliest to most recent. So click on this assignment here, put everything in order, and then we will go ahead and move on. Your first task today is to go ahead and watch this video about the Cambrian Explosion to the Great Dying. It's a really good overview of the Paleozoic Era. It gives you a really good idea and picture of what's going on during this time. From there, we're going to take notes over the Paleozoic, and then your homework is just going to be to catch up on any makeup work you may need to do, anything that you're missing. So bell work, turn it in for points, video, and then notes. Go ahead and grab something to write with, something to write on, pause the video, come back to go into the notes over the Paleozoic. So the first thing you need to know is, when was the Paleozoic? So think about that, check back through your notes, pause me, and return with an answer. Hopefully you came up with the Paleozoic is the beginning of the Phanerozoic eon, which is our current eon. So it's right after all of that Precambrian time. Paleozoic means ancient life. It was about 544 million years ago to 248 million years ago. And during this time, life is going to become more abundant, more variable. Lots of different forms of life are going to come and go. We have 6 periods during the Paleozoic. And remember that unless there's a major event like a mass extinction, our time periods kind of blend into each other. What you're going to find, though, is during the Phanerozoic, a lot of our time frames do have that clear definition in between of a major event happening. So this is what the world looked like during the Paleozoic. During most of the area, we were covered mostly by seas. You can see the Rodinia supercontinent down here is breaking up, starting to move around, and eventually it's going to all move towards the center, going north to south, and we're going to end up with Pangaea down here. This is an animation. If you click that link, you can follow along and see all of the changes in the Earth that happened during this time. So our first time period that we're going to look at in the Paleozoic era is the Cambrian period, from 570 to 500 million years ago. This begins with the Cambrian Explosion, which, remember, is not a big boom. It's a lot of life showing up all at once in the fossil record. One of the very earliest organisms that we are able to find fossils for is called a trilobite, and that's this guy down here. Lots of oxygen in the atmosphere, lots of life. Rodinia is starting to break up, so we no longer have a supercontinent. They're all kind of moving around. The next one is the Ordovician period, 500 million years ago to 435 million years ago. We still have lots of oceans. There's more and more life showing up in the oceans. We're starting to get vertebrate fish. Reef complexes are going to be things like corals. And then we're going to have our first mass extinction event at the end of this period. It's going to be because of global cooling. It's going to send us into an ice age. And because of this ice age, almost everything is going to die off. We end up with 2 pieces of Rodinia. The southern one is Gondwana, down at the South Pole, and then near the equator you have Lorasia, which is where North America is going to be. Our next time period is the Silurian, 435 million years ago to 395 million years ago. Lots of land plants are appearing. We have jawed fish, animals on land, arthropods that look like insects or spiders. You've got a fossil down here that's one of the very clear examples. Some artwork of what things may have looked like during that time. One of the cool things about the Silurian period is the sea that is covering North America is actually covering the Midwest here, and it's very shallow. But we do have evidence of this sea existing because we have that massive cave system in the Midwest here, especially in Missouri. We have limestone and dolomite caves, and in some of those we actually have fossils of corals, which are oceanic organisms right here in the landlocked Midwest. In about a minute, I will put up some cards in the upper right corner, and you can follow those to a video on Jacob's Cave, which is one of the caves here in Missouri that has some evidence of the Silurian Sea. There's also going to be a video for Monument Rocks, because in our next time period, the Devonian, the sea is going to recede, but then in the Cretaceous period, we're going to get covered again. And Monument Rocks is going to talk about the Cretaceous sea that we have. So this image is during the Ordovician and Silurian periods, when most of North America is covered by that shallow sea. The light blue is shallow water, dark blue is deep water, and the yellow represents exposed land. There's not that much here in the North America region that's exposed. So this is a close-up image of what North America would have looked like during that time. You can see we're kind of tilted on our sides because the equator is going through the middle here at an angle. So North America is tilted on its side around the equator. And you can see that there's different parts of North America that are exposed during the different times. The Appalachian Mountains are going to be exposed for pretty much all of it. Mountains form when two land masses collide and push up, and so those are very high regions of land. The Devonian comes next. This is our age of the fish, 395 million to 345 million years ago. So we have insects appearing, amphibians start moving on to land. Forests are beginning to show up. As those seas recede, we get more and more trees. And then this period is also going to end with an extinction event. So about 60% of all species are going to die off during this time. And this is again going to be due to global cooling. The temperatures just get too cold for species to survive. Here's what we're looking like. So you have Lorasia, which includes North America, up here near the equator. We've kind of shifted down a little bit here. And then Gondwana down here on the bottom. Our next time period is the Carboniferous period. This is split into two ages, the Mississippian and the Pennsylvanian. 345 million years ago to 280 million years ago for the Carboniferous period. North America was near the equator again. We have reptiles appearing. We have amphibians diversifying. Animals are able to spread out and move into locations that they were not able to live in before because of other organisms that were there. A lot of our forests are swampy. We have all of those oceans and seas that were receding, and it leaves behind a marshland. So think along the lines of Louisiana swamps and marshes. During this time, organisms that die off are going to get buried, and they are eventually going to become our current coal supply here in the U.S. Insects during this time were gigantic. These are comparisons next to the size of a human male. So they're huge. I would not want to run into a scorpion that was this size. Craziness. A lot of the organisms during this time were just ridiculously large. Carboniferous, we're going to start seeing Pangea come into existence. All of the continents are going to start moving together again. And now we move into the Permian time. 280 to 255 million years ago, Pangea is fully formed here. The Appalachian Mountains are forming. As Pangea forms, it closes up all of those oceans and seas. So the middle of Pangea becomes dry, so our climate really dries out. We're no longer marshy, we're more kind of tropical at this point. Reptiles are going to diversify. We start seeing some mammalian-like qualities in organisms, and the things that die during this time period get buried, and they are actually going to become our oil deposits. One of the reasons Texas has such a good oil so many good oil fields is because of organisms that died during this time. Again, We're going to have a massive extinction at the end of the Permian. Here's a quick view of Pangea when it's fully formed. And our Permian mass extinction, we're going to lose 90% of our organisms in the water, so our aquatic life. Land animals, which are terrestrial life, we're going to lose 70%. Scientists aren't completely sure what caused it. They've got a lot of ideas: volcanoes, climate change, sea level changes, asteroid impact. They're not 100% sure. A lot of those can be linked to climate change. We just don't have enough evidence to be able to say 100%. Lots of species didn't make it. Our friend the trilobite is no longer with us. Lots of amphibians, sharks, and mollusks are going to die off. Mostly what's going to survive here is going to be smaller organisms. So here are the next few slides are going to be some snapshots of Permian life. Go ahead and go through these on your own. Pause the video to look at each slide and kind of take stock of what is around, and then you will be done for the day.